In Chapter 4, we learn about stereochemistry. Now, before we get into really thinking about what that means, we have to define what stereochemistry is. And what stereochemistry means is the structural and chemical consequences of the arrangement of atoms in space. So, digest that a little bit. We're going to be looking at the three-dimensional structural consequences and also thinking about the chemical consequences of the arrangement of atoms in space. And remember, we've talked about molecules being three-dimensional. Trying to represent them on a two-dimensional piece of paper is sometimes difficult. And oftentimes we have to really think about what that molecule looks like in three-dimensional space. As an example, I'll show you 1,2-dimethylcyclopropane. So 1,2-dimethylcyclopropane, if you think about it being flat, you would say, well, there's only one way to draw it. But in reality, there's the cyclopropane itself can be thought of as a plane, and the two methyl groups can be on different sides of the plane. So I can have the two methyl groups being on the same side of the plane, and we call that cis. And I can have the two methyl groups being on opposite sides of the plane. And of course, we would call that trans. So just like cis and trans alkenes, we have cis and trans cycloalkanes. Now, the problem though gets a little bit more complicated than that, because notice the way that I drew this particular molecule on the right hand side, this trans isomer. I drew the methyl on the left coming out at me and the methyl on the right going behind me. But I could have drawn it like this. And this is also trans. This is a different arrangement of the atoms in space. I want you to think about that for a moment. And if you can't see that the two structures on the right that are representing trans 1,2-dimethylcyclopropane are different, you need to get out your model kit. They are different. In order to go from one to the other, I have to break bonds and remake them. I can't orient this in such a way that that basically they are identical or superimposable on one another. So they are two different representations of trans 1,2-dimethylcyclopropane. So we have cis, and then we have two different representations of trans. Now, those two representations, the two structures of that trans 1,2-dimethylcyclopropane, are stereoisomers of a different kind. And we say that the molecule is chiral. Chiral. So cis 1,2-dimethylcyclopropane is achiral. It is a stereoisomer, but it is achiral. And we'll get into the reasons for that in a little bit later on in the chapter. But trans 1,2-dimethylcyclopropane is chiral. Chiral simply means handedness. It comes from the Greek word chire, which means hand. And if you think about your left hand and your right hand, they are essentially mirror images of one another. But they are not the same. You cannot superimpose them on one another. So they are chiral in nature. And there's lots of things in nature that are chiral, and we're going to be looking at molecules that are chiral and looking at both the structural consequences, the physical consequences, and the chemical consequences of those chiral molecules.